What we're going to talk about today is kind of a status update of bin validation 1.1. But what I will try to do is show you concretely how things will be able to change in your applications in the very near future. So first of all, I'm not acquainted to Nostradamus in any way. Specification until the last moment where, we send the PDF and is approved by the committee might change. So if for some reason some of the features I'm talking about do not make it or some additional make it, don't get a grudge on me. So as I said, what I want to do is first give you a quick 10-minute reminder on what bin validation is and refresh in your mind the concepts that I will be able to build on top of in 1.1. Also because I'm sure my accent is a bit weird, that will give you 10 minutes to adjust, so that's good. And as I said, I'll try to emphasize, why it is useful for you and where you could use that in your applications. So my name is Emmanuel Bernard. I work for Red Hat in the JBoss division, the everything around middleware. And I'm what they call a data platform architect. So everything around data, I'm trying to get involved to coordinate the various projects. But specifically speaking, I've been historically part of the Hibernate team, and I'm still coding a lot in this area. Hibernate OGM, which is it's basically our experiment to try and use Hibernate, but to store data into a NoSQL store instead of a relational database. We thought it would not work, but we didn't make it fail yet, so we're continuing. We just did a big release today. Have a look at in.relation.2. That's the blog, the team blog that we're having. So yeah, have a look. Hibernate search is about full text search for your applications. So kind of Google, but for your applications. All your entities are actually indexed in Lucene, and we offer kind of an object-oriented approach on top of what you would get in Lucene. The focus is really about ease of use and things like that. Hibernate Validator, of course, which is related to bin validation, so I won't mention that much more. And Ceylon. Ceylon is it's a new language for the Java platform, but also that can be compiled in JavaScript. And the idea is, how would Java look like if we were able to start from scratch today, learn from the mistakes, and redesign not only the language, but also the SDK? So that's a team led by Gavin King, and they've been working on it for quite a while. Have a look at ceylon-lang.org to see where they are at. Yeah, I'm also participating in specifications. Of course, bin validation. I'm the spec lead of bin validation. I'm also trying to participate in Java persistence when I have time. I'm also animating a couple of podcasts. The first one is about the JBoss community in general. It's every 2 months, so you can all put it in your iTunes feed, and you won't be overwhelmed by it. The second one is in French, so I'm not sure it's going to be a big hit here, but yeah, you never know. So let's first remind you about bin validation, the core concepts, and why we did this specification. So before bin validation, what you had is you still had constraints and validation, but you were applying them at several layers of your application, right? In your presentation layer, maybe you had an XML-driven validation framework that you were using, let's say, some struts validation, something like that. Then at the business layer, you had either manually coding the validation or using some kind of validation framework as well. Then your data access layer, let's say Hibernate, would also provide some rudimentary validation capabilities. This stuff should not be null. This should be limited to 50 characters, things like that. And of course, beyond Java, you had your client side that needs to validate data before passing it to the server, and your database has constraints, right? You define a table with some constraints on it. This column should not be null. This var arg should be 50 characters, these kind of things. And these were duplicated all over the place, right? So the idea behind bin validation is were twofold. The first one is let's try and stop duplicating the data everywhere. Let's define the constraint once on our domain object, and let other framework actually reuse those constraints when they need it, right? So when I'm pushing some data into, when my presentation framework is pushing data into my bean, into a bean, then you will be able to look at the constraints here and apply the constraint instead of me having to duplicate the data at the presentation layer. And that's the same for the other layers, right? So you define the constraint once, and it's reused by everybody all over the place. And by standardizing it, we actually make it more safe, I guess, for a framework to actually say, you know, I'm not going to try to reinvent the validation framework. I'm just going to reuse the standard here and use the metadata or even the engine to execute the validation. So that was the goal, but to actually push it to success, we also started integrating with a few JSRs, right? JPA, every time you create, update, or potentially remove an entity, we also validate the entity to make sure you don't put, you know, bad stuff into your database. JSF, which is a presentation framework, every time you push form data into a bean, we look at the constraints, apply the validation from bean validation, and return an error message to the user on the actual field if there is a need for it. And CDI basically has the ability to inject a validator or a validator factory to be able to actually call the validation framework directly. But we started with the JSRs, but we also make our extension point quite open so that other framework could actually reuse the same logic and same semantic. We've seen, you know, since bean validation has been out, a few key projects actually, you know, embracing that. Spring has been a very early adopter. GWT has even rewritten on the client side the bean validation, you know, specifications, pretty cool. Other presentation framework like Wicked, Tapestry, and many others actually have integrated with bean validation. So if you're in EE, that's awesome because it's all integrated. Even if you go beyond EE, that's still awesome because other frameworks have actually catched up. So how do I write a constraint? Well, a constraint is literally an annotation, and I put that on the property I want to validate. So in this case, I've got an address with a few fields, and I'm applying some constraint on it. Some of them are standard in the spec, not null, size, and some actually are extension written by the user, let's say a custom zip code, right? So the specification lets you write custom annotations and custom constraints for your application. There's another one here, add valid. It means that when I'm validating address, I'm also validating the country. So I'm cascading the validation of the address from the address object to the country object. So when I get the list of errors, the list of constraint violations, I'm actually getting the one from address and the one from country. If you pay attention here, what you see that it's focused on a property. So what you get is the property. We validate the value of the property, and we say, you know, yes or no, it's valid. But what if the validation actually depends on several properties? Well, you can put the constraints at the class level, and what you get is the actual class instance, and then you can just drill down and do address.getCountry and address.getZipCode. So based on the country, you might apply different zip code strategies, for example. Groups is another important feature that is, you know, somewhat advanced but quite useful in a few areas. The key idea is to say, you know what, I don't want all the time to validate all the constraints, right? So instead, how about we define a default group in which constraints belong to if you don't put anything. But then I can define specific additional groups and put constraints into those specific groups. So the idea is to actually validate a subset of the constraints and not all of them, right? The use cases are various, but the key interesting one are partial validation. I'm receiving some data, putting it into my object model, but I haven't received all the data. So my object, I know my object is not valid. How can I actually validate the part that I've already received without, you know, triggering violations for the part that is not yet completed? Well, I can put those constraints in a subgroup. That's what groups are made for. The other one is to do something based on the state of an object or an object graph. Think about Amazon and the buy in one click button, right? I can buy in one click if the user has a default credit card, default shipping address, and maybe has accepted the buy in one click policy. Based on the state of the account object, let's say, I'll be able to display the buy in one click button or not. I could create a group that says, can buy in one click and put the constraints here on those constraints. I can also use group to order constraints. By default, constraints are not ordered. The engine actually decides in which order it wants to go and validate things. But in some cases, you want some, more control, and you can use that. So what's a group? A group is an actual interface. And what you're doing is you say, you know what, this not null constraint is actually belonging to the group basic poster. On the other hand, the code checker constraint belongs to the full postal group. So depending if I want a complete address checkup or even just a basic address checkup, I'll use the basic postal group or the full postal group. How do I do that? Well, from the validator, I do validator.validate. I'm passing the object I want to validate, and then the group or the list of groups I want to validate. It's actually about R here. Good? I told you can write your own constraints. How do you do that? Well, two things. You need an annotation, and you need the implementation actually implementing the validation logic. So the annotation is just a regular annotation with 3 properties, message, group, and payload. And then you can add custom properties like for size, mean, max, those kind of things. The other key thing is that the annotation is annotated with constraints and points to the actual implementation of the constraint, right? So when I'm validating a zip code and the properties of type string, I am actually going to call string zip code validator. And string zip code validator implement the constraint validator interface, and I said that I'm accepting zip code of type and the property of type string. And I need to implement 2 methods. Initialize, which gives you the annotation, so I can retrieve, specific properties. The second one is valid. Basically, I should return true if it's valid and false if it's not valid. Very simple. We try to focus on the validation logic, and the engine takes care of the messaging, error report, and everything like that. Good? All right, so that was bin validation 1.0, and we're going to talk about what is new and what is coming up for bin validation 1.1. First of all, it's not exactly a feature, but we made the spec very, very, very open. It was kind of in our gene pool to do that because we, came out of the Hibernate validator lands, and everything we do tends to be open source and in the open. But bin validation 1.0 was kind of in the middle here. What we did for 1.1 is actually open up everything. So there is a website where you can read up the news, the latest information, the latest version of the spec. Every time literally somebody commits something to the spec is built again and pushed to the website like within a minute. Everything we discuss is done in the open through the mailing list or the issue tracker or the website. So you can always A, participate, and B, see where we came from for a given feature and the reasoning for going one way versus another. The other interesting thing is that everything is open source. The specification, the reference implementation, which is Hibernate Validator, the TCK, which is the stuff that, bin validation provider actually use to make sure they are compliant, and even the website. So if you find a typo on the website or want to write something, feel free to fork it, get a fork on a Git, Git repository fork, apply your change, send a pull request, and you're good to go. So that, as I said, I'm pretty proud to be like a 100% compliant fork me on GitHub specification. Who knows about GitHub, by the way? All right. People who don't know, just well, right after my talk, go to github.com. Very interesting way to work, and it has literally increased the interaction and community and feedback all over JBoss. So have a look. So openness is, one of the features. The second one is dependency injection. You could already get validator and validator factory injected into your CDI component or Java EE component, generally speaking, but we wanted to go beyond that. Basically, we wanted to make every bin validation component injectable. Not injectable, but receive injection points. I'll talk about which components are actually involved here, but the idea is to make sure that you can write a CDI bin as any of those bin validation components. But because we didn't want it to stay tied to CDI, we actually created an abstract contract for those kind of lifecycle integration between the component, creation and suppression, so that, Spring or Juice, could integrate that, even Avalon. Who remembers Avalon as a dependency injection framework? Damn, I'm the only one. It's a very old one, probably one of the earliest in Java. It's long dead though, so don't worry. So how can I use dependency injection inside bin validation? Any constraint validator implementation can actually inject a CDI bin or a Spring bin if it's integrated with Spring and so on and so on. And that's probably the most interesting use case for you, but the other use case is any message interpolator implementation, traversable resolver, and constraint validator factory are also managed bin from a dependency injection point of view. So instead of us handling the creation and deletion of a given object, we dedicated that to the various containers. Let's look at an example. Going back to my zip code validator example here, I'm doing some basic validation first, but then I've got a dedicated service that actually checks for the zip code validation. If, let's say, if it's the US, I've got an actual zip code checker that goes to USPS and verify that the zip code is valid beyond my, regular expression validation. So what I do is simply use the add inject, just like I would do in any CDI component, and then use it within my isValid method, or initialize if there is a need for that. Okay? Actually, I've got a question for you. One thing we could do as well is to say, you know what, for message interpolator, traversable resolver, and constraint validator factory, the way to customize them today is to define in validation.xml the actual implementation you want to use. An alternative could be to use some kind of annotation-based qualifier and a provider from a CDI point of view to say, you know what, the default message interpolator I want to use as an application is this one. So please pick up this one instead of the one from XML or even the default one. I don't know if that interests you. Think about it and, come back in the Q&A session and let's have a discussion about that. Because message interpolator, traversable resolver, and constraint validator factory are somewhat very framework-centric interfaces. I'm not sure that's very useful as a feature, but if people have use cases, we'll definitely try and address that. The other big feature we have added is method validation. So method validation, the idea is to say, let's put constraints on the parameters and the return value, and if there are constraints, let's go and validate them right when we call the method, right? So think of them as literally an interceptor. You're calling the method, and then bin validation kicks in and say, you know what, let's look at the parameter values. Are they valid or not? If they are valid, we go through and go and execute the method. If they are not valid, we get the list of errors and create a constraint validator factory, constraint violation exception and send that back to you. We execute the method, get the return value. If the return value is valid, that's fine, we give that back to the client. If it's not valid, again, we raise an exception. We made sure to provide the right metadata information so that interceptor technologies could just skip the whole interception if there is no constraints on it, right? So you can very easily check if a method should be intercepted and actually intercept it or not. So bin validation doesn't try to be an interception technology. So what we decided to go for is simply to say, let's build integration between interception technologies and bin validation, so we provide the default, bin validation interceptor implementation. So for CDI, that would be, CDI interceptor based. For Spring, that would be the same. If you use AOP, you'll use, the actual point cuts implementation or something like that. So that means that if the interception technology actually do not intercept the method for one reason or another, then bin validation won't be called, right? So for example, if you use proxy-based technology to intercept data, if you call from an outside, bin to a given bin, then you'll be intercepted. But from within a bin, you will not be intercepted because you're already beyond the proxy and you literally do a direct call. If you use something like AspectJ, that's not going to be the case, right? So we have some limitation, which are literally the limitation of the interception technology. Don't worry about that because in many cases, the interception is already the right thing for you. Why? Because we mainly focus on business method interception. I'll talk about that in a minute. Second thing I wanted to mention is that it works not only for methods, but also for constructors, right? So when you create an object with a few parameter values, you can validate those parameters and raise an exception if something is wrong. So why do you want method interception? There's a few use cases. The main one is to say, you know what, this method is actually exposed to people I don't trust, so I want to make sure the parameters that come in are actually valid. And let's say I don't trust myself to code something properly, so the return value should be also validated so that the client is sure to get the right type of object within the constraint boundaries, or an exception would be raised, okay? So you come in, a user passes a list of parameters, these parameters are valid, and then you can go and execute the method. The other interesting side effect of that is that instead of having your method actually validating the parameters first and then going to the actual code of the business method and then, continue over, you push the constraints validation as a cross-cutting concern, a declarative cross-cutting concern, and the business method is actually focused on the business. The other thing I wanted to mention is it's somewhat similar to the programming by contract paradigm, where you literally declare the constraints of your method input and outputs, and this is actually validated by the runtime. So in many ways, it's like Javadoc, but actually that is validated at runtime, not just ignored. So that's good. So that's how you would do it before bin validation method validation. So here I've got a client that creates a user by using the account service. I'm passing a few parameters and I'm validating some of those parameters. And if those parameters are not what I expect, I raise some kind of exception. So that's doable, but it kind of mixes the validation logic from my actual business logic, so it's a bit annoying. The second thing is that here I'm raising an illegal state exception, but maybe the developer next to me will raise the specific other exception, and you would not get any kind of standard way to retrieve this information. So here is the version where we use bin validation. Instead of putting the constraints on the getter of the object, we put them on the actual parameter. So here we say, I'm creating a user, and the username should not be empty, and the email should A, not be null, and B, be an actual email. And the date is also constraint. And then I go and actually write my business method. And what's happening is that the interception logic go and raise the exception, validate the parameters and raise the exception if something goes wrong. Otherwise, the method is actually executed. Make sense? That works for simple types, but that also works for bean themselves. So if at some point I pass an actual user to my service object, I can use the add valid annotation to say, please go and validate this user object and make sure all the constraints within the user object are actually valid. And I can also apply the constraints on the return value. And in this case, I just put the constraints on the method, because the return value is literally defined in the method declaration. So here, I'm sure that when I create an order, it's never null. The client is sure that it's never null and that the order is actually a valid order object. Okay? And if you're familiar with bin validation, that's exactly the way you would declare your constraints in bin validation on the getters and the setters. Right? So all the knowledge you've learned from bin validation, you can reuse it in method validations here. So, two things to remember. A, it depends on the actual interception technology. So if you use CDI, that's going to be a CDI style interception. So typically, to go from one bin to another, you'll have the validation activated. The second one is constraints in many ways are just like an extension of the actual Java type system. Instead of having a string, we actually have a string that should be an email. Okay? It's sort of an extension of the type system. So we also respect the list of substitution principle, which basically says that when I have a contract, as a client of this contract, I expect to be able to use any implementation of this contract without breaking, providing I respect this contract. Which means that a subclass cannot actually add more constraint to a given defined contract, right? If I've got an interface and an implementation, if the implementation is more restrictive than the interface, something is wrong. So the parameters cannot be more constraining than the interface. Likewise, on the return value, it's sort of the opposite, because I can get any return value that is as constrained as defined by the interface. It could be more constraints. I'm okay because I'm receiving the value, so I don't care. But it cannot be less constrained because I'm expecting that, right? So it's the same principle you use in subclassing, just we apply it for bin validation here. We had a kind of a huge debate in the expert group as to whether we offer a flag to disable this kind of restrictions. We decided not to standardize that yet because breaking those rules is just wrong from an object-oriented point of view. But it's probable that bin validation provider will implement some kind of proprietary flags, and if they become extremely popular, we'll probably standardize that quickly. Okay, so we had method validations, we had dependency injection, those were the two biggie, and let's talk about group conversion. Group conversion is, in many cases, not necessary, but without that, some of the definitions are quite complicated. So the idea here is to say, I've got an object O1 that is associated to an object O2, and it has the add valid annotation on it. So when I'm validating O1, I'm also validating O2. By default, if I validate O1 with a group A, I'm also validating O2 with a group A. But sometimes O2 actually has, specific groups that are, specific to O2, and I don't want that to leak into the client of O1 validating things. So what group conversion allows you to do is to say, you know what, when you're validating group A for O1 and you're about to validate O2 within this object graph, please switch A to B and go validate O2 with a group B. Okay? It's kind of network address translation technology, but for validations. So that looks complicated, but an example is actually very, very simple to understand. In this case here, I've got a user which has an address, a home address. And when I'm validating the user, I'm also validating the address. And remember, address has had two ways to be validated, the basic postal validation logic or the full postal validation logic. How do I do one versus the other? How do I decide from a user point of view to use one versus the other? I don't really want to force the people validating user to remember that, oh, well, actually there is a link to address, so use basic postal versus full postal as a group, right? So the way to solve the problem is to use the group conversion thing I was talking about before. Here I'm saying, you know what, when you validate the default group, which is the specification default group, go and validate the basic postal group for the address object. But when you validate the complete group, which is a group specific to user, then I'm going to go and validate the full postal group here. So it makes it much easier to reuse the address object in many different contexts without having to leak this kind of group information all over the place. Are you guys okay so far? Good. The second thing, the last big thing I want to talk about is the integration with other specifications, and specifically JAX-RS. The idea of method validation was actually partly designed to help us integrate with JAX-RS. If you think about bean validation and the areas where we have integrated with other specifications, those were at the boundaries between Java and other areas. JSF is the link between HTML and Java. JPA is the link between Java and your database. And if you think about JAX-RS, it's the link between HTTP or the machine-readable way of accessing the web and Java. Okay? So it would be interesting to make sure that when a method is called from a JAX-RS point of view, the parameters are valid, right? And also be sure that the return value is valid when we return it. And that's what we did. You literally can... Oh, sorry about that. So you can validate any of the objects you would be able to receive from a JAX-RS point of view. HTTP headers, query parameters, and even entity bodies. I'll talk about that a bit later. And that's exactly how you would do it for method validation. You do the same for JAX-RS methods here. And what's interesting is that the way to return the errors from a bean validation point of view is to raise an exception and get the list of constraint violations. But from a JAX-RS point of view, we don't have exceptions, right? There is HTTP error codes. So what the JAX-RS expert group did is do a binding between the HTTP error code and the actual exception going on. And the beauty of it is that there is a nice distinction between having an improper parameter and having a constraint violation here versus an improper return value and a constraint violation here. If the parameter is incorrect, that's the user's fault. So that's a HTTP 400 something error code, right? Whereas if the return value is supposed to be valid but it's not, that's kind of a server fault where we expected to get something correct, but some developer has been somewhat lazy and didn't write the unit test he should have, right? So we raised a HTTP 500 error code and give that back to the user. And the body of the HTTP response actually contains the information about the violations. So how is it done? Here we have an example of a resource bound to the path user that we validate. And what we have here is to say, you know what? First name is bound to the form parameter first name, same for last name and email. And I'm putting some constraints on these objects. So what's going on here is JAX-RS actually do the conversion from the HTTP world to the Java world. And right before calling this method, the actual register method, actually calls bean validation, validate the parameters, and return an error if something is wrong. Otherwise, we go and carry on with the actual validation, the actual execution of the method. So that works for headers, query parameters, and form parameters as method parameters, but it also works if you put the binding between the headers, query parameters, and form parameters as getters of user or fields of user resource. Just like you can put some constraints on the bean, we can do the same for the user resource. So in many ways, the user resource becomes the bin validation, valid bin, and then you're good to go. So you can validate headers, query parameters, and form parameters, which are somewhat simple types, but you can also validate more complex objects. The entity bodies that would bind, let's say, a JSON representation of an item object. So what's going on here is that JAX-RS transforms the JSON stream into an item object, and the item object is actually validated by bin validation as an object. And because of the add valid, all the constraints on item are actually validated. And by the way, we also make sure that item is not null. Okay? So it's very natural. So if you learn bin validation in one area, you'll be able to use it all over the place in a unified way. Otherwise, that's either my fault or the other guy's fault, but we're going to have to fix it for you to get a unified vision of things. So that's the big features I wanted to talk about. I didn't try to cover all the internal bug fix or even internal features we've added to do our inside kitchen. So I only talk about the user visible features. The other one I want to quickly mention is instead of being able to validate strings, we actually went one step higher in the hierarchy to validate any char sequence, which means you can also validate string builder and string buffers. Interpolations is being improved, and instead of being able to receive, well, A, have a template, which is already supported, B, receive the actual value of the constraint parameters, which is also supported, you can also receive the improper value and display it into the message. And we're going to add the formatter syntax, the Java formatter syntax into the mix here. The other features are min decimal and max decimal now have an exclude flag to be able to exclude the boundaries when you go and validate things. The last one is, so it's an interesting one. Most validation implementation actually ignore if the value is null. If it's null, that's okay, let's return true. Otherwise, if it's not null, then go and try and validate it. Why do we do that? Because if a user wants a nullable email, he put @email on a string, and it can either be null or be a valid email. If I want an email that is never null, I put @notNull and @email as a user. Okay? So that's why most validation actually let the null value go through, right? But it's a bit annoying because you have to explicitly add this line of code that says if it's null, just go through. Instead, we'll try to make a nice declarative approach to say, you know what, this constraint actually should ignore null values. So don't even try and call me if you have null values. That's more for constraint validator implementers, but many applications actually do write their own implementers. So when can you get that? Well, we released the draft a couple of months ago, and we also implemented this draft as Hibernate Validator 5 Alpha 1. Don't be scared by the Alpha 1, it's just that it's a work in progress because of the specification, but otherwise the features are fairly mature, so don't be too scared about that. Otherwise, about the future, we're going to plan a new bin validation draft somewhat by the end of October. Try and do a release, within the same vicinity, maybe early December, something like, mid-November, mid-November, something like that. But our goal is to get the spec fully released by end of February, at least pushed over to the JCP, and the JCP takes a little while to stamp, a specification, so it should be validated somewhat around March. That's the goal we have in mind anyway. If you want more information, go to binvalidation.org. Let me quickly show you the website, actually. There we go. You missed that one. It's, fairly simple website. You can get the actual latest draft of the spec. You can also look at the roadmap that shows you our priorities and what we have done, and even the proposal we have started. So here we've got we've classified everything from must-have to, would be nice to have, or next version. For each of them, well, we have an issue open for it. And then sometimes we have actually written a fairly detailed proposal where we discuss the thing with the expert group and, keep the open question open and try and resolve them. And of course, when they are completed, we put a nice stamp on them, and they are actually literally pushed to the spec, and we move to the next thing. So A, if you disagree with this list, come and talk to us. And B, if you're interested in solving one of those problems, come and talk to me. The goal of my life is to delegate as much as possible to other people. So if you guys can help me do that, that would be nice. Thank you, and yeah, let's open up for questions. Yes. Okay. So the question is, there are two specs, 303 and 349. What's the difference? Actually, every time you go and do a new specification, even a new version of the specification, you actually start a new JSR. So it's literally a new expert group that actually does bin validation 1.1 compared to bin validation 1.0. In practice, it's pretty much the same expert group and the same spec lead. So 349 is literally the improvement on top of 303. Yes, it's 1.1, exactly. Yes? Yes. So the question is, in Hibernate Validator, we have a add script assert, I believe, that is a constraint that lets you write a Groovy script or any, I forgot the name of the spec, right? Any script language supported by the JVM. Write your constraint as a script and then let it be validated, right? Is it going to be part of the spec? We didn't have planned to do that, but if you're interested, come and make your case to the expert group. That should be a fairly easy one to add, actually. Yeah. Right. Okay, I see. Right. So the second part of the question is that, well, if the script starts to become more complex, then I've got multi-line stuff, and it's kind of boring and annoying from when you write that down in Java with multiple strings, literally. And it would be nice to actually point to an actual script file. So yes, that's a good idea. We should definitely do that for Hibernate Validator, and let's see later on for bin validation. But B, you could also use Ceylon and have a very nice multi-line multi-line string representation. That would work too. Right. Right. But I think that's a good one. Please open an issue on Hibernate Validator's Jira issue tracker, and I will definitely try and do that. The second thing I wanted to say is I hate scripts because they are opaque from A, when you read quickly, you don't realize what's going on, and B, you don't have the metadata to know really what's going on, and it becomes a black box. So that's why I'm a bit reluctant to add those kind of stuff, at least in the spec. Yes? Yes, it does. Constraint validator has actually a path to the actual property that is being that is wrong. I'm sure I wrote the spec. Which one is it? So that's Hibernate Validator. To try and come to the forum or open a Jira issue, I'm almost certain we have it covered because. Seriously? Okay. Okay. Well, let's talk about the talk and show me what's going on. Because I know the TCK actually verify that thing. So. Maybe one more, yeah. Well, the script assert actually is, would be one way to do that. Expression language is in many ways just like yet another scripting language, just more compact. So that would be one way to do it. I'm not sure that there is a bridge between the, the JVM interface and an actual EL implementation link, but that might be possible. So you could do it that way. The other solution is to have a more complex constraint validator implementation that would actually get some parameters dynamically injected from somewhere else, somewhere in your environment, maybe a file system, something else, and then you can get something very dynamic here. Yes? Yes. Yes. That's an interesting question, right? What you're saying is that it's always annoying to have to literally call validator.validate, pass the object, and imperatively call the bin validation. And that's on purpose because one of the goals of the spec is really to get other specifications lifecycle taken into account. And every time there is a natural lifecycle for validation, go and call them. So you in your code don't have to do that. Method validation is something is about improving this state of art, right? There is no add validate because by default method validation will be validated if there is a constraint on the parameters or the return value. Otherwise we just skip it. So it goes into what you're thinking about, and that's the right thinking. That's really where we want to go. So we try to add more and more specification integration between bin validation and others. It takes a long time, but we're trying to improve every day. Yes? I would love that. So the question is, sometimes all the validation go through until you reach the database and you've got, probably the more interesting one is the unique key validation, right? Violation. And wouldn't it be nice to get the unique key violation specific exception from Oracle being translated into a bin validation exception? Yes, that'd be nice. I'm not sure how to actually solve that problem. I would love to do that. That would require for JPA to standardize somehow the constraints and expose that as a standard exception one way or another, and B, do this conversion between the JPA exception and then the bin validation one. If you have some ideas, I'm interested into that. Yes? So it's not correct. API is actually to call and validate stuff, but to put a constraint on an object, you've got either an annotation or XML. Got it? So you literally have a declarative way to express constraints. The most common use case is to use an annotation, but if you cannot touch your code base, you can use XML for that. Hibernate Validator has a programmatic way to actually express a constraint programmatically, but that's not, oh, okay. Yes, that's not part of the spec yet. It's a lot of work to standardize it properly, and we couldn't do it in this version of the spec. Did you have any more questions besides that, or? Yeah, that would be the intermediary solution, but definitely a programmatic API would be nice. Hopefully the next rev or something like that. Yes? Yes, that's the default behavior. So by default, we don't want the user to say, sorry, this email is wrong, and then, oh, sorry, the password is wrong, and then the guy is like, yeah, So what we do is validate the whole object graph and give you the list of error reports and bring that back to you. Yes? Yes? So I'm trying to meet, forgot the name of the person, but I'm trying to make the expert lead here and try to see if we can do something here. Right. Yes. I actually did the work at some point of reading all the constraints you can express in a XSD schema and do the binding between that and the basic annotations in bin validation, and that's 99% covered. So you just need to sit down and see how to properly standardize that. Again, that's, we have many things to do, and that's on the roadmap. For JAX-RS. Okay. Yes.
So every time I compile, those go away. I'm giving you transfer schema validation and scheme validation.
But they don't.
Custom validation.
So, well, how do you express a custom validation in XSD, right? That's a problem. But one way to do that in bin validation is to use composition. So instead of writing your own massively custom annotation, what you do is use composition to say, you know what, this zip code validation is actually a size limitation and maybe a regular expression. So you literally, the add zip code annotation is annotated with add min and max to 5, and then add pattern to have a regular expression. And then you can potentially add an additional implementation here. So you can literally build a constraint on top of others. And even if the complex one cannot be understood by, let's say, XSD or, I don't know, when you push that back to your database schema, the more modular ones can actually be understood, and at least those ones can be applied. So that's one way. Oh, yeah, I see. Right. Well, okay. I'm not an XML expert. I've spent the last 10 years of my life fighting it, but yeah, that's a good idea. Yes. I see a couple of ways. You could actually call the validator to unit test your validator directly. That would be easier. The annoying part is you need to create an annotation literal to pass the annotation to initialize if you do something here. many use cases don't actually need injection for their validator implementation, so you don't have any problem here. You can just validate them that way. And C, you can use, many CDI, many dependency injection containers can be bootstrapped quite lightly, so that would be one way. There is no magic solution. If you depend on a database connection to validate something, well, you're a bit screwed. Except if you do the actual, actually maybe no, because what you could do, let's say you use Weld, right, the CDI implementation. You could just say, I'm providing an alternative implementation to the injection service that would be a mock-up, and then, carry on that way. That would be one way. It requires a lot of effort for what it is, but that would be one solution. Yes? Oh, I get that. That looks about right. Have a look at the Hibernate Validator test suite, because, we have a bunch of, we actually use the programmatic API to artificially put constraints on objects that don't really have them, so that we don't have to actually build an artificial object with the constraints we want to validate on top of them. So we were lazy. That's why we created the programmatic API. One more question, maybe? Yes. Sort of. We have a notion of template. So by default, we say use the fully qualified class name of the constraint dot message as the key of the error. And then in your resource bundle, you can associate this key to whatever message you have. So it's not exactly a specific way to assign a code to an actual message, but you could use it that way if you want to. Yes. There is placeholders for other constant defined in your resource bundle, placeholders for the attributes of the constraints. So let's say min and max, the value can actually be passed around. And there is going to be the wrong value will be passed around, and you can put it that way. Well, thanks everyone. It was a good feedback session, so thanks. And if you, open issues for all the, not so much question, but, requests you had, and when you think that makes sense, we're going to try and improve the product. Thank you.